Okay, guys, good morning. So today we're going to continue with the lesson from yesterday, which we don't do too often, but sometimes I just feel like, you know, a 25-minute lesson is going to be less effective than two 12 or 13-minute lessons. So rather than stretching it out so long, I think it's better sometimes to break things up and give you guys a little more time to work. So as far as aim, you can continue from yesterday's aim. We're not going to do a do now today. We're going to kind of just jump right in because we have a lot to get to. So we said yesterday that we had two-step equations that involve addition and multiplication, as well as addition and division. And we talked about addition and division, so this is going to be the addition and multiplication portion. And the rules are the same, right? So I have my variable term on the left. I want to eliminate that negative 11, so I add its opposite on both sides. Negative 11 plus positive 11 is 0. Negative 4 plus positive 11 is positive 7. And we bring down x thirds. So how do we deal with x thirds? Well, x thirds is x divided by 3, and the opposite of multiplying, dividing by 3 is multiplying by 3, right? Because what's going to happen if I multiply by 3? Well, technically I get 3x divided by 3, and 3 divided by 3 is 1, which gives us x, and 7 times 3 is 21. What would our check look like? Well, of course, we're going to rewrite our original. We're going to substitute. Here the parentheses aren't so significant, though it's not a bad idea to put them in there for consistency's sake, I suppose. 21 divided by 3 is 7. And negative 4 equals negative 4. Okay, that's our check. That's our proof that x is in fact equal to positive 21. All right, so this is kind of a different one, just because we have what's called a binomial, or two terms in the numerator. The approach really isn't going to change, though. Right, I'm going to multiply both sides by the denominator, right? If x, some expression, right, in this case it's x minus 5, is divided by 7, if I multiply something by 7 that's divided by 7, it's like multiplying by 7/7, which is 1. So we end up here with x minus 5 is equal to 70, right, which is going to give us 75. Now when I go back and check it, 75 minus 5 is 70. 70 divided by 7 is 10. Now it gets a little bit harder now. So I'm going to show you how to do this in 3 steps, which is not ideal. And then we'll talk about how we can use some of our prior knowledge to do this in 2 steps. So the variable term is on the left side of the equal sign. So we're going to add 3 on both sides. Now, maybe it's a good time to call into to mind what both sides means, okay? Not that it's really come up yet, but both sides means both sides of the equal sign. And we're going to see this in a few days when we get to variables on both sides. That equal sign's like our barrier. It's like the dividing line in our triple beam balance, okay? So anytime we're talking about both sides, that's what we're talking about. All right, so I'm adding 3 on both sides, positive 3. Negative 3 plus positive 3 is 0. Negative 9 plus positive 3 is negative 6. And we'll bring down 2x fifths. So I'll rewrite this, right? 2x divided by 5 is equal to 6. So one approach would be multiply by 5 to clear the denominator. So multiplying by 5 and dividing by 5 is like multiplying by 1. So that gives me 2x is equal to negative 6 times 5, which is negative 30. And if 2x is equal to negative 30, I can divide both sides by 2, and x equals negative 15. So let's go back to that second step, right over here. 2x divided by 5 is equal to negative 6. So I'm thinking to myself, how can I do this? You know, right? The lesson says 2-step equations. I should be able to do this in 2 steps. So 2x fifths is really the same as saying 2/5 x. Right? Because what's 2/5 x? It's 2/5 times x, 2/5 x, right? Just to think about what this really is 2/5 times x. Well, x has a denominator of 1. When we multiply fractions, we multiply the numerator and denominator, so there's our proof, right? X divided by 3 is the same as 1/3 x. 2x divided by 3 is the same as 2/3 x, just to put it in some context. All right, so let's get back to what we're doing here. So if that's really 2/5 x, based on what we talked about a few days ago, I should be able to multiply by the reciprocal. What did I do over here? I multiplied by 5 and then I divided by 2. Wasn't that the same as multiplying by 5 halves? That's what 5 halves is. 5 multiplied by 5 divided by 2. So, well, I don't expect everyone necessarily to do it the way that I'm doing it over here. And then negative 6 times 5 halves is negative 15. It will make it a 2-step equation versus 3 steps. Do I care which way you do? Not really. The way in the right is a little bit more sophisticated, but if what's on the left makes more sense to you, then that's what you're going to do, right? In general, guys, I don't care what method you use as long as it's mathematically valid and we're not using like shortcuts and cheats and stuff like that. This one should be, I think, a little more straightforward. It kind of ties in with the last one, right? So I've got my variable on the left. I need to eliminate the positive 2 by adding its opposite on both sides. Positive 2 plus negative 2 is 0. 14 plus negative 2 is 12. So now I'm looking at 3/4 x is equal to 12. So at this point, I think we've done enough of this, and we even just reviewed it. But we should remember, right? One-step equation, fractional coefficient, multiply both sides by the reciprocal. Right? What's 3/4 times 4/3? It's 1. Right? 12/12, which is 1. What's 4/3 of 12? Well, I know 1/3 of 12 is 4. 4/3 of 12 is 4 groups of 4, which is 16. Right? And if we check it, 3/4 of 16 is 12, and 12 plus 2 is 14. All right, guys, so there's your now try. So this is where you're going to pause, you're going to solve and check. All right, so you can unpause, and I will go through them now. I will check one of them because I haven't checked one in a while here today. So I want to isolate my variable term, x divided by 5, meaning I need to eliminate the negative 9. So I'm going to add positive 9 on both sides. That gives me x divided by 5 is equal to 4 plus 9, which is 13. I will rewrite that as a one-step equation. If x is being divided by 5, the inverse is multiplying by 5. Technically, that will give me 5x divided by 5, which is simply x. And 13 times 5 will give me 65. I'm going to put the check down here. Right, so what's my check? Well, the first thing I do is I rewrite my original equation, right? That's step 1. My second step is I think x is equal to 65, so I'm going to substitute, and I'll keep it consistent with the parentheses. So 65 divided by 5 is 13 minus 9 is equal to 4. And we're going to make sure we finish the check, okay? In other words, a lot of us will I have noticed you left the check there. That's not horrible, right? I know that I can see that that's a number sentence like you'd see in kindergarten or first grade, that 13 minus 9 is 4, so I understand that. But you really want to wrap it up and show the equality, that both sides are the same exact number. Let's talk about the second one now. So I want to isolate 1/4 x. I'm going to add its opposite on both sides. We're going to be careful with our signs. Positive 3 plus negative 3 is 0. Negative 5 plus negative 3 is negative 8. And we bring down our 1/4 x. I will rewrite this. 1/4 x is equal to negative 8. I'm going to multiply both sides by the reciprocal. What's the reciprocal of 1/4? Well, it's technically 4 divided by 1, which is 4. So 1/4 times 4 is 1, so we've got x. Negative 8 times 4 is negative 32. If I go to check it, 1/4 of negative 32 is negative 8. And negative 8 plus 3 should give us negative 5. All right, guys, so again, right, we talked about yesterday about two-step equations involving addition and then division. Today we looked at addition and multiplication. So we're going to do our addition step, right? We're going to think about what term do I need to eliminate. Whatever's on the same side as the variable, I'm going to add its opposite to both sides. And then I'm either going to multiply, so here I'm multiplying by the denominator, right? Because again, dividing and multiplying by the same number is just like multiplying by 1, so it gives us a coefficient of 1. Or if I've got a fractional coefficient, I think about multiplying by the reciprocal, which is what we did for the last two. All right, same deal, guys, right? I'm giving you 4 of them. I'm not giving you 8 or 10 or 20. I expect to see the check. So you're going to rewrite. So if we're going to go through the first one, again, like we did yesterday, you're going to write the equation. You're going to show me that you're adding 7 on both sides. That will give you x divided by 4 is equal to 11. You're going to show me that you're multiplying both sides by 4, and that should give you x is equal to 44. Now, just a word of advice here that I didn't mention because I didn't think about it until now. Right? When we've got this, right? We want to make sure that we're showing the multiple. We're not going to do something like this, times 4 times 4. We really don't want to use x's for multiplication ever, because this to me is going to be very confusing, right? If I have an x and one's a variable and one's a multiplication symbol, that's going to be confusing. Do I want to use the dot? No, I don't really love the dot either, because that looks like a decimal. So what should I really be doing? Well, when I'm solving this equation, I'm going to use parentheses to multiply, right? So guys, as we're kind of moving up in the world and transitioning into real kind of, 8th grade and into high school algebra, that's what we want to be using for all our multiplication, right? No x's, no multiplication dots for the most part. We want to be using the parentheses. All right, guys, so although you're going to solve and check those 4 for homework, any questions, comments, concerns, as always, we'll talk about it in Google Classroom.